Let us start the lecture. In this lecture, we are going to discuss about the power in an AC circuit. First of all, we have to know what is power. Power is our time rate of change of work or energy. So, no. Then just here, the rate at which electrical energy is consumed in an electric circuit is called its power. As we know, we have two types of circuit. One is our DC circuit and another is our AC circuit. So, no. In current electricity chapter, we already discussed about the DC circuit and the power in a DC circuit is. For DC, we have P equal to VI, where V is our voltage, yes or no? And I is our current. Okay. But for AC circuit, we don't have direct V or I, but we have instantaneous EMF and instantaneous current. What you have? We have E equal to E naught sine omega t. Here this E is our instantaneous current. So, sorry, instantaneous EMF. This E naught is our peak EMF. Yes or no? Similarly, I is our instantaneous current. I naught sine omega t. Then if we have to find the power, then we have to multiply instantaneous EMF with instantaneous current. Okay. Here power is our, but here we don't have to calculate the power only. We have to here we have to calculate the average power. Then for average power we have different formulas there. So let's just derive that formula. First of all, we have to discuss about the average power associated with pure resistive circuit. Pure resistive circuit means in the AC circuit containing resistor only. We know in the phasor for that is, if we have voltage along this direction V, or we can say E also here. This is our E naught. I naught is also this direction, yes or no? And for that we know in AC circuit containing pure resistor we have E equal to E naught sin omega t and I is our I naught sin omega t. And there is no phase lag between E and I. Yes or no? So then how have to find the power? We know for power P can be written as dW by dt, yes or no? Or also we can write for SC E into I, instantaneous EMF into instantaneous current. Or we can also write E naught sine omega t into I naught sine omega t. This one. Then what we got is just here. Our dw by dt becomes, then dw becomes E naught I naught sine square omega t dt. This one. Then we have to integrate dw so that we can get total work done w. This one. Then integrating both sides. What we got here? Just see. Integration of dw. For dw, we have to take the limit from 0 to w, and for dt, we have to take the limit from 0 to capital D, that is for full cycle. Okay. Then what we have? E naught I naught is constant, so just take outside of integration. Then in place of sine square omega t, we can write 1 minus cos 2 omega t by 2. How can I write that? Because we know cos 2 theta is our 1 minus 2 sine square theta. Yes or no? We can write here also. Then we can get E naught I naught upon 2 in bracket 1 into dt. Here you can get dt. Then cos 2 omega t into dt. Here you get cos 2 omega t dt. Okay. Then what we have? As you know, for complete cycle, cos and sine function gives 0 value. So this cos function gives us 0 value. Okay. Then integration of dt is our t. If you put the limit from 0 to t, then you can get t minus 0. Yes or no? Hence here you can get w equal to E naught I naught upon 2 into t. So, or you can write w by t, which is equal to E naught by root 2 into I naught by root 2. So this w by t is our average power. So this average power becomes, in place of E naught by root 2 we can write E RMS. In place of I naught upon root 2 we can write I RMS. Okay. Then for pure resistive circuit or AC circuit containing pure resistor, our average power becomes E RMS into I RMS. Okay. This is our required formula. Then we have to find the average power associated with a impedance circuit. Impedance circuit means the circuit in which both capacitor, inductor, and resistor are present. So that from that we can get the average power associated with pure inductive circuit or pure capacitive circuit. Okay. For average power associated with the series LCR circuit, okay, that is the impedance circuit. Then we have a phasor there. That phasor is just like this. In this direction we have VR. Then along this direction we have VL minus VC. Along this direction we have E. I is along this direction. Yes or no? So here we know current lag behind the EMF by phase phi. So here we can write the instantaneous EMF and instantaneous current as current lag behind EMF by phase phi. So we can write I as I naught sin omega t minus phi. And after then as it is, we have to find the power. Yes or no? For power, we can write P equal to dW by dt. And for AC, we know the power is our product of instantaneous EMF and instantaneous current. Here we have instantaneous EMF E naught sin omega t and instantaneous current I naught sin omega t minus phi. So far just multiply that one. Then what you got here? Here we have sin omega t minus phi. We have a formula sin A minus B. We know for that sin A into cos B minus cos A into sin B. So let's just use that formula here. Okay. Here we use the formula sin A minus B. Sin A minus, this is our A, this is our B. So sin A into cos B minus of cos A into sin B. Then we have to multiply. By multiplying, we can get sin square omega t cos phi minus sin omega t cos omega t sin phi. So then also we can write just here we have sin omega t into cos omega t. If we multiply t here and divide 2 here, then what we got? 2 sin omega t into cos omega t is the formula for sin 2 theta or sin 2 omega t. Yes or no? In place of 2 sin omega t cos omega t, we can write sin 2 omega t. So we can replace the term as sin 2 omega t upon 2. Yes or no? After that, we can find the total work done. Okay. So for that, we have to integrate the this equation actually. Okay. Then just integrate that on. Here we can say integration of dw. For dw integration, we have to take the limit from 0 to w, and in RHS we have the term dt, so we have to take the limit from 0 to capital T. Okay. Then we just replace this sin square omega t as 1 minus cos 2 omega t upon 2. Okay. Did you see here? We just as e naught I naught is constant, so we just take outside, and then for in place of sin square omega t, we just write 1 minus cos 2 omega t by 2. As you know, 1 minus cos 2 theta is our 1 minus 2 sin square theta. So then just see here what I have to write in the next step. Then just see here what I did here. We just multiply. We just take outside 1 by 2. Okay. Then this becomes e naught I naught by 2. Multiply 1 into cos phi into dt. Cos phi dt. Then cos 2 omega t cos phi dt. Okay. Then the third term is our sin 2 omega t sin phi dt. Okay. Then we have to integrate. As we know, over a complete cycle, cos and sin function is 0. So this cos 2 omega t becomes 0. And this sin 2 omega t also becomes 0. We can find the integration also. We can uh, get that value 0. Okay. We don't have to write that. Directly we have to write. As cos phi is a constant, so just take outside the integration of dt, and for complete cycle this becomes 0. This also becomes 0. Then this is our final work done. Yes or no? This work done is our E naught I naught upon 2 cos phi into 2. Then what have to write? We can write W upon T becomes E naught I naught upon 2 cos phi. Yes or no? Then after then This W upon T is our P average. This is our average power. In place of E naught, I naught by 2, we can write E naught upon root 2 into I naught upon root 2, and then cos phi. E naught upon root 2, in place of E naught upon root 2, we can write E RMS, I RMS cos phi. This is our final required formula for average power associated with series LCR circuit, or you can say also impedance circuit. Then some special cases there. First, just discuss about the resistor. If a circuit have only resistor, a circuit containing only resistors, then we know there is no phase lag between the EMF and current. So here we can get phi is our 0. As phi 0, so cos 0 is our 1. Then our P average becomes E RMS I RMS, and we got this well actually, yes or no? Then what is about inductive and capacitive circuit? Just write down for inductor only. For inductor, we know the phase angle between the EMF and current is 90 degrees, or no? And we know for inductor, actually the current lag behind the EMF by phase pi by 2. Then cos phi is our 0. That is cos 90 becomes 0. As cos 90 is 0, so our average power becomes 0. Yes or no? After then, we have another third circuit is there for capacitive circuit. For capacitor also. For capacitor also, we have phase angle pi by 2 between EMF and current. And in capacitor, we know the current lead EMF by phase pi by 2. Phi is our pi by 2. So cos pi by 2 becomes 0. P average is our ERMS IRMS cos phi, that means ERMS IRMS cos pi by 2. As cos pi by 2 is 0, so we can get here P average power is a 0. Okay. This is all about the lecture.